So side-side angle or angle side-side does not work. No bad words in Mr. Newman's class. No bad words in Mr. Newman's class. This, when you have two sides and a non-included angle, it is not enough information to prove triangles are congruent. This does not work. When you have two congruent sides and the included angle, that does work. That does work. Okay? However, when it's two sides in the non-included angle, this is not enough information. No bad words, Mr. Newman's class. Do not use this acronym. Okay? Side-side angle does not work. Moving on to the next one. Well, these are extremely similar. What if you have two congruent angles and then one congruent side? What if you have those three pieces of information? What happens to be that both of these work. That both of these work. I'll give you a quick example of one of them. Again, you don't have this diagram anywhere, but you can just watch and follow along. For these two triangles here, I've got that this angle is corresponding and congruent to that angle. And then I've got that this angle is corresponding and congruent to that angle, and this side is congruent to that side. So obviously I have two angles and one side. You need to figure out which acronym you're going to use. Even though they both work, you need to know which one you're using. So it all comes down to, where is this side located? Is it, like the acronym, in between the two angles? Is that where the side is located? Is it the included angle? Sorry, included side. Or is it the non-included side? Is it the side that's not in between these two angles? And so for this example, where is the side located? It's in between. It's the included side. So which acronym are we going to use? Someone with confidence? Angle, side, angle. So again, this is your test answer. Yes, comma, triangles are congruent by angle, side, angle. If we had the vertices, if we had those labeled, then you would also write a triangle congruent statement. Like triangle ABC is congruent to triangle XYZ. But that's not labeled this one, so we can't do that. The next one here, angle, angle, angle. I think we discussed this last class. Does angle, angle, angle work? No, it does not. And so for those of you who maybe weren't here, I have a triangle that's written down on this piece of paper. Now, if I outline this triangle, I cannot change the angle measurements of this triangle that's currently being projected onto the board that's written down on that piece of paper over there. I can't change the angle measurements. But I can zoom in. So as I zoom in, obviously that triangle's getting bigger and bigger and bigger. Am I changing the angle measurements though? No, I'm not. Does anyone remember from 8th grade? Or maybe even 7th? The three interior angles of any Euclidean triangle, those three interior angles have to add up to how much? How many degrees? Yes, ma'am? 180 degrees. So as I zoomed in, this triangle, these three angles, they add up to be 180 degrees. As we zoomed in, we didn't add degrees and take degrees away and redistribute how many degrees each angle had. We just zoomed in. It still adds up to be 180 degrees. What this is this is an example of two similar triangles, and there's a whole different section on similarity that we'll get to after the Christmas break. But for now, you just need to know and focus on congruence. Angle, angle, angle. If you know the three interior angles are congruent, that does not produce or does not ensure that the triangles are congruent. They're definitely similar, but not congruent. And on our test, we're actually going to write not enough information, because we don't know whether or not they're congruent. There's just not enough information. They could be congruent. but there's just not enough information. You guys use this every day on your cell phones. Whenever you zoom in on a photo, like, man, I am so out of touch with like celebrities and stuff like that. Who's a good-looking female celebrity?
Jennifer Lawrence.
I have no idea who that is. I just heard someone say Steven, so okay, we're clearly off with that. But anyways, okay, Hunger Games girl. So if we have a picture of her, she's a beautiful woman, beautiful actress, very talented. Well, if we zoom in on her, she's not going to turn into Shrek, right? Like, everything's going to stay proportional. All those angles are going to stay. It just gets bigger. So that's the whole thing about angle. It produces a similarity, but it does not change the interior angles. It doesn't change the proportions of her face and so on and so forth. So it doesn't change the proportions, it doesn't change the interior angles, but obviously they're not the same size and same shape, so they're not congruent. So we'll get to similarity and we'll talk a whole lot about that. But for now, you need to know that it does not produce congruent triangles. The last one that you should have written down, HL, stands for what? Hypotenuse leg. Okay, and this one does produce congruent triangles. However, HL is only allowed to be used on what type of triangles? Right triangles, because right triangles are the only ones that have hypotenuses. However, it's kind of a catch-22, I feel, because I saw this pattern with last year's students, and previous years before that as well, but they just got stuck in this mindset that if you had right triangles, then the only way to prove that they're congruent is using hypotenuse leg. That's not the case. If I have two right triangles, I can prove that those two right triangles are congruent using side angle side, or angle side angle, or angle angle side. This is just an extra one that only works on right triangles. So please do not get in the habit of once, like on a quiz or a test, if you see a diagram of two right triangles, don't automatically assume, oh, it's got to be HL. Like, I have to prove these triangles are congruent by HL because it's a right triangle. That's not the case. In this diagram, do we know anything about the hypotenuses? No. We don't know anything about the hypotenuses. We know that these two triangles have these segments that are congruent and corresponding. And if these two segments are perpendicular, and this is a right angle, that means this is also a right angle. And I know that all right angles are congruent. And then these two triangles share this segment. So I can confidently add that mark of congruency, because if two triangles share a segment, that segment's congruent to itself. Who remembers the property? This segment is congruent to itself by which property? Reflexive property of congruence. And we'll talk more about that today. We did talk about it last class. So now we have that these two triangles have this side and that side that are corresponding congruent. And then this angle and this angle that are congruent and corresponding. And this side that they share. So these triangles, yes, they are congruent, but not because of HL, but because of side angle side. So please do not get in the habit, do not get into that that pattern of seeing right triangles and assuming you have to use HL. It's just another arrow in your quiver. Sorry. It's just another way of you proving that right triangles are congruent. Okay? So now let's do some examples together. So you had that worksheet. It was a half sheet of paper. It's a half sheet of paper. I'm going to attach this on the website. So if you rewatch this video or whatever, or lose this, it'll be attached on that page. So you can refer to it. So some of us, I can see as I walk around, some of us took the time and really worked this through and kind of struggled with it and wrestled with it and figured out what information do I know, what can I add to the diagram, if any, and then tried to prove whether those triangles are congruent or not. Some of us, I don't know, quite the opposite. You're staring at a blank piece of paper right now. A little discouraging, but for those of you who did do this homework and did go through every single example, what we need to practice is not only determining whether or not the triangles are congruent, but we need to practice writing those congruence statements. So right now, together, we need to add some vertice names so that those of you who did this work, you can just take the time right now and practice on naming these triangles. So for number 1, what I need you to add to this diagram, it's currently being projected on the board. This is everybody. You need to add this to your diagram. We're going to label these vertices. We're going to say that this vertex right there is A, and then we've got B up at top, and then C, and then D. So please add these. Now that we have these vertices labeled, we can now go back and write a congruence statement, which we were unable to do without them. Going straight down, number 3, please label your diagram exactly like mine. X, Y, Z, and W. Everybody is labeling these 4 points so that we can write triangle congruence statements. Below that, you've got R, T, S, P, Q. Okay, doing these problems, the first thing you need to ask yourself is, am I allowed to and can I justify adding some sort of marks of congruency to the diagram? By justify, I mean, can you back up whatever you put in the diagram with a postulate, property, theorem, or definition? You must be able to justify whatever you add to the diagram. So for number 1, we clearly have that this angle here is a right angle and that angle there is a right angle, and all right angles are congruent. And then I have that this angle here with 1 mark of congruency is congruent to that angle there. That's only 2 pieces of information. This is an angle, and another angle. So do we know a 3rd piece of information, or is there just simply not enough? Where's the 3rd piece of information?
On that side that are shared, the side that's being shared.
And what's this side called?
It is the leg. No.
Just name that segment.
Oh, AC.
Okay, segment AC.
AC.
All right.
Yeah.
So these 2 triangles share segment AC. Now, if this were a proof, which it's not, but if it was a proof, which we will get into later, you would have to write that segment AC is congruent to segment AC. And we've added that mark of congruency to the diagram. You didn't have to put 2. You could have put 1. That's just showing that that is congruent to itself. You could have put 3. It doesn't matter. We're just showing that these 2 triangles share segment AC, and segment AC is congruent to itself. How? By what? Reflexive property. But you're not going to stop there, are you? Of what?
Congruence.
Congruence. Please make sure that your statement, this is a statement, matches your reasons. So if you're going to say that these 2 objects are congruent, then this is property of congruence. Property of congruence. Now, it's not necessary that you wrote this for this problem, but I'm letting you know that this is going to be necessary in proofs. You're going to have to justify why segments that are shared are congruent to itself, and that's the property right there. So now I've got my 3 pieces of information. I've got that 2 corresponding angles and 1 corresponding side are congruent. So I know that whatever acronym I'm going to choose has to involve 2 angles and 1 side. So I have to just determine, am I going to use angle, side, angle, or angle, angle, side. They both work, so I know the answer to this question is yes.